Good morning, guys. In previous classes, we continuously discussing ellipse. Okay, in ellipse, we completed the standard form of ellipse, and we see that in previous classes, definition of ellipse. Okay, in ellipse, we see that two foci and two vertices, and we see the two directories. Okay, now when the conic is said to be ellipse is nothing but SD by PM equal to V, where E equal to 1 it's form a parabola and E less than 1 it forms a ellipse and E greater than 1 it forms a hyperbola. Okay, in ellipse we have the weightage is nothing but 8 marks. We get two short answers 4 plus 4 in this chapter. Okay, by reduced syllabus from board of intermediate we have only one exercise on ellipse. And next we see that the types of ellipse are various forms of ellipse and notations we will see in this video. Okay, today we are going to read various types of ellipse. Now in a parabola we see the different forms of various forms of parabola. How it is forming means to rotating the axis, okay, anti-clockwise we can get four types of parabola, and again shifting the origin one place to another place we get that for another four types of parabola. So totally we get 8 types of parabola. We see that in parabola chapter. And coming to ellipse, majorly we have only two types of ellipse. To rotating the axis with anti-clockwise direction we may have two standard forms. Okay, now we clearly we know that by, so first which is any y axis and this is the x axis and which is a ellipse. Okay, which is one of the ellipse. To rotating the anti-clockwise direction with 90 degrees we see that another diagram, we can see another diagram. Right, another ellipse. Okay, this is another ellipse, another standard form of ellipse. To rotating the axis with the anti-clockwise direction, okay, with 90 degrees we get this ellipse. Okay, to forming this ellipse, here we know that clearly the center is C and here the focus S and this is vertex A and we have the directrix line and this is a foot Z. This is L equal to 0 and here another focus S dash and another vertex is A dash and foot it is Z. Okay, now center is 0 comma 0 and the lactives rectum, and this means here we see that this is AE comma 0 and minus AE comma 0. Here this is A comma 0 and this is minus A comma 0, and here the distance it will be A and this B and B dash and this distance will be B. So here standard form is x square by a square plus y square by b square equal to 1, where always a greater than b. Why? Because the distance from C to A is A and C to B is B. Here the distance from C to A is less than C to B, so therefore C to A is bigger. Okay, bigger than CB. So here x square by a square plus y square by b square equal to 1, where a is greater than b. Now from this diagram we can Observe, as usually, similarly here we have the same type. As usually means it is nothing but center, and here we can see focus, and this is a vertex, and here directrix, and it is z, this is l equal to 0, and here also a focus s dash and vertex a dash and foot z dash, and this is l dash equal to 0. Okay, and here this is say here major axis, it is a major axis, and it is a minor axis, it is a minor axis. In this case it is minor, it is a minor axis, and it is a major axis, it is a major axis, and here the focus is nothing but 0 comma be, and this value can be taken as 0 comma minus be, and it is also 0 comma b, and also 0 comma minus b, and here we see that this is b and b dash, it is a comma 0 and also minus a comma 0. Okay, now the directrix line, we'll see that here x equal to a by b, and here directrix line y equal to b by e. The directrix line x equal to a by e and y equal to b by e. Now from these diagrams we can see that the major axis is along x-axis. The major axis is along x-axis. Okay. Now the minor axis is along y-axis, or directly we can say that the major axis is x-axis, minor axis is y-axis, and length of major axis, and the length of major axis is nothing but 2a, and length of minor axis, the length of minor axis is 2b. Why? Because this length also considered as 2b, a plus a 2a and b plus b 2b. Okay. Next, center c equal to 0 comma 0, and forces here s of ae comma 0, and here s dash of minus ae comma 0, and directrix equation, and here directrix x equal to a by e, and directrix is x equal to a by e, and vertices we know that a to a dash is nothing but, okay, and another one is nothing but eccentricity e equal to square root of a square minus b square by a square. So this is a eccentricity. Okay, same as usual in this diagram we can see that same as usual similar points. Okay, now here major axis, here also major axis, the major axis is y axis, and minor axis is x axis, minor axis is x axis, and length of major axis, the length of major axis is nothing but 2b, and here length of minor axis, is 2a, and center c equal to as usual 0 comma 0, and forces is s of 0 comma b, and here s dash of 0 comma minus b, and directrix Here we will see the directrix, y equal to b by e, and eccentricity. Here eccentricity is nothing but y eccentricity is e equal to b square minus a square by b square, where which is a standard form x square by a square plus y square by b square equal to 1, where always b greater than a. Why? Because this length is considered as b. This length is considered as b, and this length is a. So here b is greater than a in this diagram. So just simple modifications we have from these two standard forms. Okay. Another two forms we have. Another two forms mean the center can be origin can be shifted to another center, that is h comma k. So we get here x minus h whole square by a square, and y minus k by whole square by b square equal to 1. And here major axis is same, minor axis will be same. The length of lattice rectum, here these four all will be same. Here we can see that some of the modifications we will see in these concepts. Okay, now those are not mainly not important, we can see that. Now again we have some notations. We have another point from this diagram, that is length of lattice rectum. Very important, the length of lattice rectum, which is perpendicular to focus. So that is here ends of lattice rectum L to L dash, that is a e comma b square by a, and here a e comma minus b square by a. So these are the ends of lattice rectum. So therefore length of lattice rectum, so length of lattice rectum, the length of lattice rectum is 2b square by a. The length of lattice rectum is 2b square by a. And here length of lattice rectum, length of lattice rectum, here 2a square by b, here 2a square by b. Now where it is length of lattice rectum, here this is perpendicular to focus, so this is L and this is L dash. Okay, so here we see that value become here a square by b comma be, and minus a square by b comma be. These are the ends of lattice rectum. So therefore length of lattice rectum is 2a square by b. Now after seeing the length of lattice rectums, we have some notations. We have some notations in ellipse. So notations. What are the notations in standard form of ellipse? Standard form of ellipse can be denoted by s equal to 0. This means x square by a square plus y square by b square minus 1 equal to 0. S is a standard form. And first one, if s1 equal to 0, this is x1 by a square and y1 by b square minus 1, 0. And second one, s11 equal to 0. Here also replace x1, so x1 square by a square and y1 square by b square minus 1 equal to 0. And third one, s12 equal to 0, then implies x1 x2 by a square and y1 y2 by b square is minus 1 equal to 0. These are the some of the important notations. And point locate point on ellipse. Locate the point on ellipse. Locate point on ellipse. Locate point on ellipse means if S11 equal to 0, if and only if the point lies on ellipse. The point lies on ellipse. If S11 equal to 0, the point lies on ellipse. If S11 is less than 0, if and only the point lies inside of the ellipse. Inside of ellipse. Point lies inside of ellipse. Suppose if point S11 is greater than 0, then implies the point lies outside of the ellipse. Point lies outside of ellipse. Okay, so these are the important notations and locate a point on ellipse. Okay, now next we can see further video. Okay.